Let's compute z-scores. A z-score, often just noted as z, is how many standard deviations a value is from the mean. So if we think about a number line where mean is in the middle and mean is 0, then anything that is above the mean is going to be positive. And anything that is below the mean is going to be negative. And as I mentioned, if it equals the mean, it's going to have a numerical value of 0, or a z-score of 0. Okay, so the formula is z equals x minus mu over sigma. And I'm kind of a word person, so I like to say the z-score equals the data value minus the mean over the standard deviation. So when I'm writing this out, z equals x minus mu over sigma, I always say the words because that helps me remember. Okay, so let's see what we know. Your research shows the average salary for your position is $42,800 with a standard deviation of $1,800. If your salary is $46,200, how does it compare to the mean? Meaning, let's compute the z-score. Okay, so what do I know? The average is 42,800. So the average is the mean, 42,800. The standard deviation, sigma, is 1,800. Your salary, that's the data value, is 46,200. Now, you know already that your number, 46,000, is more than 42,000. So you know your z-score is going to be positive. Okay, so z equals data value minus the mean over the standard deviation. Let's plug in what we know. So z equals 46,200 minus 42,800 all over 1,800. Now, it's super important that you do the numerator first. So 46,200 minus 42,800 gives us 3,400, and we're still dividing by 1,800. When we do that, we get 1.88888, and it goes on and on and on. So that rounds to a z-score of 1.89. So what this means is that your salary is 1.89 standard deviations above the mean. That's really good. I mean, if you think about average, you know, most data falls within 2 standard deviations of the mean, either above or below. So 1.89 is on the high side, which is really close to 2, which means you're on the high side of salaries for that position. So that's great. A baseball pitcher throws a fastball at 88 miles per hour. Of all pitchers at a showcase, the average fastball was 89.6 miles per hour with a standard deviation of 1.75. How does this pitcher's fastball compare to the mean? Okay, what do we know? The pitcher throws 88 miles per hour. That's our data value. We know that the average was 89.6, so that's mu, and standard deviation of 1.75. So, again, z-score equals data value minus the mean over the standard deviation. Plug in what we know. Z equals 88 minus 89.6 over 1.75. Again, know that 88 is less than 89.6, which means that this pitcher's fastball is lower than the average, so it's going to be negative. So when I calculate the numerator, I get negative 1.6 over 1.75, which gives me a negative 0.91 rounded to 2 decimal places. So this pitcher's fastball is 0.91 standard deviation below the mean. So maybe at this showcase, right, where these pitchers are trying to get recruited or drafted or whatever, maybe they say, we're only looking at people within 1 standard deviation of the mean. Anything outside of that, we're cutting them. We don't need them, right? It's possible. People do all kinds of things like that. So we can calculate this based off of what we know. And we can use z-scores to compare, which we're going to do in a different video.